Understanding the basics of recursion.
Recursion is when a function calls itself to solve a problem in smaller steps. It's a fundamental concept in coding, especially for tasks like traversing data structures or solving mathematical problems. Before diving deeper, it's crucial to grasp how recursive functions work and how each call builds on previous results. Remember, every recursive function needs a clear stopping point.
The importance of a base case.
One of the most common pitfalls in recursion is forgetting the base case. The base case is the condition that stops the recursive calls. Without it, your function may call itself endlessly, causing a Stack Overflow error. Always define a clear and reachable base case that ensures your recursive process will terminate safely.
Avoiding infinite recursion.
Even with a base case, improper logic can still lead to infinite recursion. This usually happens if the function doesn't move closer to the base case with each call. Double-check that each recursive step modifies input parameters in a way that will eventually trigger the base case, preventing unending loops and errors.
Managing stack overflow and memory limits.
Every recursive call uses memory to remember its place. If your recursion is too deep or lacks a proper base case, you can hit a stack overflow. To avoid this, try to write functions with minimal and necessary recursion depth. Sometimes converting deep recursion into an iterative loop or using tail recursion optimizations can help.
Handling edge cases and input validation.
Not all inputs behave as expected. Forgetting to handle edge cases, such as empty lists, negative numbers, or 0, can cause incorrect results or errors. Always validate function inputs and consider unusual scenarios when designing recursive solutions. This creates robust, reliable code that behaves correctly in all situations.
Testing and debugging recursive functions.
Testing recursive functions can be challenging because errors may not appear immediately. Use simple examples to trace each function call and check intermediate results. Debuggers and print statements can help visualize the call stack. By thoroughly testing different inputs, you can spot and fix issues early.